Hello, today I'm going to talk about spring phenology and trophic mismatch that can occur in a changing climate. The timing and appearances of biological events is known as phenology, whether it be the budding and blooming of trees and plants, the arrival of spring migratory birds, and many other natural events that rely on timing as the seasons change. Biologists study phenology to gain a better understanding of interacting species. Farmers use it to plan the sowing and harvesting of food, and plants and animals rely on phenology for reproduction, migration, and other sources of sustenance and survival. The way species interact with each other is often reliant on phenology, but in a changing climate, when the timing of the species' life cycle changes, the interactions between species can also change. When interacting species alter the timing of their life cycle phases at different rates, phenological and trophic mismatch can occur. Trophic mismatch is the lack of synchrony between consumers and their resources and is a concern in a changing climate, especially because this synchrony is often reliant on temperature, day length, and a predictable climate. Today we will focus on the early coming of spring and how this is affecting many species and the way they interact with their environment and each other. The arrival of spring has been documented by humans for centuries, and in more recent times, this phenological event has been occurring earlier and earlier. Plant and animal life cycles are a good indicator of this type of event, and by observing the earlier arrival of spring, humans can see the trophic changes that are occurring. Often, the earlier arrival of one species directly affects the life cycle of another, and in a changing climate, this can cause some issues. An example of this is in Europe between the pied flycatcher and their prey, the caterpillar. The peak abundance for the caterpillar is becoming earlier in the year as the climate warms, but unfortunately the flycatcher is not able to match this peak. The flycatcher is a migratory bird, flying up from Africa in the spring only to find that it has missed the native caterpillars. This is resulting in declining populations because the reproduction of the flycatcher and chick hatching is not corresponding to the peak available food sources. Species phenological mismatch, in this case, may result in a bottleneck effect and exaggerate the declining flycatcher populations where the birds are not able to keep up to their prey. Another example of trophic mismatch resulting in population declines is in Greenland with the caribou. The migrating caribou time their movement to line up with the spring emergence of plants that are important for lactation and calf nutrition. The spring emergence of these plants is becoming earlier due to the warming temperature and are known to be most nutritious at certain times during the spring. This means that the peak nutrition of these plants is becoming earlier and more condensed as the climate warms. Unfortunately, because the caribou time their migration based on day length and not temperature, this is resulting in the caribou often missing the peak abundance of these essential nutrients, and mother and calf health and survival are rapidly declining. In some cases, species in trophic mismatch will not always result in population declines. An example of this is in the Netherlands with the great tit, which also follows the emergence and peak abundance of caterpillars. As mentioned, the caterpillar's peak abundance is becoming earlier in the year due to warmer temperatures, and has advanced at more than twice the rate of great tit laying dates, according to scientists at the Netherlands Institute of Ecology. In this case, the populations of the great tit are not declining as they have with the pied flycatcher, and this is suspected to be due to decreased competition between chicks. With fewer chicks being hatched due to phenological mismatch between mothers and caterpillars, there is a better chance of survival. Decreased competition for resources between the chicks hatched at later dates may result in fitness gains, increasing survival rates, and resulting in no significant change in population. Overall, a changing climate and warming spring temperatures are often causing the spring emergence of many species to become earlier. This can create trophic mismatch between interacting species and can be detrimental to the timing of life cycle phases. The future effects of trophic and species mismatch are difficult to estimate, as we have seen that the effects can be quite variable. Because we live in a rapidly changing environment, the future effects of these mismatches are likely to be rapidly changing as well.